is on product design. So as you know, AIPMA's AMTEC, we have signed with Siemens as our knowledge partner, and we have programs on product design, CAD designing, and we have our expert, Mr. Nadeem Ansari. He is a service provider of Siemens, and I would request Mr. Ansari to please come forward and give a presentation of on with respect to the courses which we are offering, what are the benefits, and what are the job opportunities, industry opportunities in designing. Mr. Ansari, please.
Hello everyone. Hello everyone. Am I audible? Yes. So now just looking at your faces, I mean most of you are from just a college pass outs or maybe in final year, right? So it reminds me of my days when I just passed out from college, and this kind of energy which normally I can right now see on your faces is normally, believe me, very difficult after 10 or 15 years, particularly having a session post lunch is the most difficult job. People normally, I get sleepy faces and all those people are, they're sleeping. But you guys have traveled so long. Okay, you came here, you are spending your whole day just to understand what is there new for us. So I think there are a lot of people here who are from NDTF, and some of you are from mechanical or production background also, right? So almost nowadays all the colleges, they are having some sort of CAD software, right? In fact, it has been like a standard practice now to just get any CAD software, and they will be having your computer lab will be there in your college, and you will be practicing on any of the CAD or CAM software. Now, how many of you, just I want to have this session interactive, okay? How many of you have used any CAD software only? Okay, okay. Yes, I think uniform is same, so I believe all of you have used some sort of CAD software. And any CAM software? No one. How many of you know what is CAM? When we talk about CAD CAM, often when we search, it normally gives us details even on Google that this is a CAD CAM software. So we know about CAD. What is a CAM? Okay, manufacturing, yeah. And CAD means computer aided designing. So that is a basic 3 words definition, that it is a computer aided designing, computer aided manufacturing. When we say computer aided manufacturing, what does we really mean at that point of time? There are these digital, there are machines who can run by themselves, okay? And those machines normally, you just need to do some programming, and then those programs are transferred to those machines and they automatically run. You don't have to do anything, okay? You might have seen some conventional machines where you need a lot of experience and skill to just move those levers and wheels and to understand how those things works. So all those things are now automated by the help of software. So that is basically where CAM comes in. So here in AIPMA's AMTEC, what we have done is we have planned a course where you can get complete designing. You can understand what is different methods of doing the designs, and then you can manufacture those parts. Earlier in our times, I mean, no, I'm not that old right now, if you compare me with other people's, but even 20 years back when I passed out college, at that time we had only manufacturing means cutting the job, okay? Put a metal plate on the machine and start machining it. Later on, we get this 3D printing technology, which means I think just before this session, you had a session on 3D printing, and on upstairs, you might have seen those demo also. So that is 3D printing. Now, when new technologies comes, so even the software have to update themselves to adapt those new technologies. So that's where we are. I'm going to show you what and where we are moving towards. Okay, and where we started from in the very beginning. When I started my career, there was hardly any company who had a basic 2D drawing softwares, and right now almost all the companies, they are using complex 3D designing software. They have complex machines for machining parts, and then there are 3D printers also. Okay, so the challenging part here is you have to stay updated every now and then. Okay, for example, once you say I have passed out from the college, that doesn't mean that your learning should stop. The most important part here is for all of us, we have to learn throughout our life. You know, earlier doctors used to say I am practicing, lawyers used to say I am practicing. Right now even engineers has to say that I am practicing. Okay, you can never become 100% engineer, because if you call yourself I am 100% engineer, that means you will stop learning, and the day you stop learning, you will stop existing in new technologies. Okay, so you have to adapt, update your information. So first of all, I would like to thanks Arvind sir. He has, means, you know, having setting up such a center at this place, and thinking just for the career of all these students is really, means, what I can say, a kind of a charity, or you can say has invested so much efforts, and he has a vision, and I would like to first thanks for all his efforts. Okay, yeah, yeah, for complete APMA, and it is APMA's AMTEC, right? Thanks. So now, starting with okay, here. Sorry for interruption. Okay. So, starting with APMA's MTech, our vision is to reduce gap between college education and industrial experience. Okay. Once you pass out from your college, or once you're in final year, you normally have a typical industrial visit for a day or two, where you go to some company, they're machining and doing all those things, designing. You just have a look at that, and then you go back to your college. But that's not all. To actually work in a company, you have to have complete thorough knowledge of how the whole process is going on. Nowadays, I have my own training center also. So whenever I get vacancies from so many people, they normally say, I need some person who has so many years of experience. Hardly any guys say that I need a fresher. You know what is the reason? Because the fresher, they normally have only the book knowledge. Okay. So to have actual practical knowledge, you need a place like this where you can actually learn how actually model is being made, and how you can create complete mold and dies. Okay. So going ahead, we started this center. Stuck हो रहा है. Okay. the basic advantage that you get now here is teaching method. We have faculties who is not just a ex-student. He has actually worked in the industry and he knows what is actually going on. Normally our faculty is the same person who goes to the industry to update or install the software or to update them for the technology. Then every batch that we conduct here has limited seats. Okay, normally in colleges, if you see, there is a class of 30, 40 students are there usually. Here we are limited. We have limited that to maximum 7 or 8 students only. Okay, we have limited batches for each class, and the advantage that we get normally is each student get personal attention. Then whatever components that normally comes to us for actually designing, that we normally share to the students so that they get real life experience. Okay, how the components are being designed in industry and how they are going ahead for mold designing. And we have laboratory that you have already seen already. Now, in fact, among all the Siemens training centers, this is, I think, one of the only training center where we have 3D printer, state-of-art 3D printers and scanners and complete lab. Then we are also conducting online sessions. So if you have any queries, okay, if you can't travel every day, or if you have limited access, you can enroll for online classes also. Then syllabus typically has modeling, drafting. Now what is these terms? Modeling is, so you create a sketch, you create a model product design, and from there you create a 2D drawing of that component. For example, if you are having a plastic component or a fixture, you first make those in 3D, then you have to push it for either for a tool room or to a CNC machine. To send it to a tool room, you have to generate 2D drawings, top view, side view, section view. So you have to generate those drawings via using an application called drafting. Then there is assembly. You can create all the parts, assemble them together, and you can check them for the motion. Okay, that means you can actually create the digital twin. For example, knuckle joint. Okay, a very basic component assembly. You can create that, and at higher level, if you look, there are automobiles, cars are there. Okay, there are more than 10,000 components are there in a typical automobile cars. So you can assemble all of them. You can check them for the interference, if they are colliding with each other, how they are performing, that all you can have a look. Then you can for each plastic component you can automate the whole process of creating dies and molds. Then Shape Studio is something where you can create realistic images of the component. For example, before actually putting the component in the market, you can, before even manufacturing any part, you can create the realistic image of those components. And then if you are made a punch or cavity, you can go ahead and go for manufacturing or doing the CNC program of those components. So now what is Siemens? Now just few minutes ago I asked you guys, have you guys used any kind of CAD software or CAM software? So most of you raised your hand. I believe you might have used Fusion, right? I think you guys said. So there are many softwares like SolidWorks is there, Fusion, Creo, and all those softwares are there. And NX is also one of them. It is not very great. It is one of them. But which software you should learn? Which software you should learn to get yourself employed? The one which is being used mostly, right? That is a common sense. So here comes, that's why we have selected NX. The reason behind is, in all the automobile industries, okay, most of them, almost 80% are using NX. General Motors, their complete production line is on NX. Even forget about General Motors in India, which is the most popular brand in automobile, Maruti, right? So Maruti, they are on NX. Okay, so the advantage of using these companies is, if they use any software, they will be having a lot of tier 2 or tier 3 suppliers. Okay, they will be making, they will also be using the same software. so that there is a better compatibility between the component that the model that they get from the OEMs, and the same thing goes down the line. So basically NX was launched in year 2000. Earlier it was called as Unigraphics or UG, and in 2007 Siemens took over, and now they have started overtaking many other softwares, and slowly they are putting all those commands whichever are better, they are adding those commands in NX. So it is basically updating with the industries. Just give me a second. It is again. नहीं मैं डिस्कनेक्ट किया हूँ. Don't know why it got hanged. आपका करंट क्या है? नहीं, यहाँ पर जो डिस्प्ले आ रहा है. दूसरे लैपटॉप में कनेक्ट कर लेंगे इसको इमीडिएटली. दूसरे लैपटॉप में कनेक्ट करेंगे इसको पीडीए. Sorry for this disruption. Now again, as you can as I was telling you earlier, the NX is one of the software which is used for CAD, CAM and CAE, all of them. CAM is computer aided manufacturing and CAE is computer aided engineering. Now normally computer aided engineering is there for complete analysis. Whenever you make any component, you have to also cross check that component for whether it can withstand different scenario. You can put loads, you can check if it breaks on different conditions, you can put vibrations to check if the assembly will open. All those things you can do by using this CAE solutions. Then most of the industry, all the CAD CAMs field, they normally they are driven by automobile industries. Okay, and the future of automobile industry, you also know now, they are normally shifting from standard production cars to now in very near future there will be customized cars will be there for each individual user. There will be different set of options will be available. So those kind of engineering is now integrated within NX also, that you can create parts which will be 3D printed and as per the user requirement. Right now, whenever you go to automobile shop, you normally buy a car, you have only one specification. I want black color or white color car, okay, or you can give the colors. But now the new cars which are coming, you can give your complete customization that I need this kind of thing. So as per your requirement, the car will be made. So that is possible only due to the usage of these kind of softwares. Now, these are few of the industries, few of the companies which are using NX. Okay, as you can see, almost all of them are there using NX. GM, Daimler is this Mercedes brand, and your Opel, Mazda, Suzuki, Isuzu, AML, all those companies, they are using NX. So their suppliers also, by default, they go for NX. Now, mold design automation process. Right now, the challenges that are there are global competition. Okay, people are coming from China, they are coming from other countries, and market share is getting divided. Even for our the mobiles that you are using, half of them are made from other countries. Okay, we don't manufacture complete mobile or automobile also. So these are the challenges. Products are getting more and more complicated, and customers are expecting high quality in those things. So that's where normally NX comes into the picture. Coming back to the mold, how many of you have designed any mold? Okay. Yes. So you might have because you guys are from NTTF, so I thought maybe you're from that background. So you know there are some runners are there. Apart from punch and cavity, there are lot more components are there in the mold. Okay. For example, there are runners are there, water cooling is there, guide pin bushes, and you have to design all those parts. Now, when we talk about technology, so earlier, just to make a normal water cooling in the punch or cavity, what normally you have to require, you have to just put out some drilling and do the pass through the channel. Okay. Nowadays, they have updated, and something new, which is conformal cooling is there, which is normally not easily can be done by using conventional manufacturing. Okay. Even in 3D printing is there, in your metal 3D printing is also there, where you can make your complete punch within conformal coolings. Okay, so that design can also be done here, and there are multiple solutions are available. Like you can create your component, you can generate punch and cavity. Then you can create complete mold base, or you can import those mold base from standard mold base manufacturer like DME, Hasco, Futaba. There are companies are there who make those molds. You have to just select those molds from the catalog and start using those. Now, the next thing is that is there is challenges with the customer data. Now, when I say that we are using NX, not everyone will be using NX. Okay, there will be customers who are using some other softwares. There are customers who will be using SolidWorks, or there will be some customers who will be using Creo, and they will be providing you with the data, and you have to go ahead and create the punch and cavity or create the mold. So is it possible? Upstairs just few minutes ago, some guys were asking ki, can we work with my software's data to create the punch and cavity? So yes, that is also possible. So that was the primary challenge in all these surveys, that almost this survey was conducted with a sample group of 1,000 people, and there the prime challenge creating and editing design from other softwares. Okay, so NX came up with an idea called synchronous technology, where you can import, you can use those data made in another software. You can use those data made in another software and then those data you can directly make the modification. Okay, for example, if you have a model made in SolidWorks or Creo, or it is coming from another company which don't use NX, you can use those data, do the modification, and start creating your mold, irrespective of which software was used to create that model. Then once you try to create the mold, you have to first validate whether it can be moldable or not. All the components that you normally get, or if you have made your own model, you have to first check that if you can validate that is moldable or if it is manufacturable. So there are multiple checks are there which are there in the software, like DFM, which is designed for manufacturing. You can import those model, set those checks, it should be machinable, it should be machinable using VMCs, or it should be machinable using ADM process. You can define those checks and it will validate whether it is usable or not. And that is DFM. And for molded part validation also there are some options that you can check the component if it is moldable, if all the data, whatever model that you have imported, if that model is perfect or not, if there are some faces are overlapping. Because what happens, once you import data, there are always some kind of data loss is there. So you have to check the model if it is machinable, or if it means it is proper or not. So you have to check for the consistency of the data. That is also there. Then molded part validation, there are multiple checks are there. Wall thickness you can check that if it has uniform wall thickness, if it has some reverse draft is there, that also it can validate. Okay, it is a simple typical part. Okay, for example, a mobile cover is there. You can create the after creating the complete mold, if you later on decide to update the model, or if you later on decide to change the model, okay, complete mold base will update. Not just mold, complete mold base will also update. There are mold base libraries is there, which I explained earlier also, that you can import those mold base from another mold base manufacturer and you can have them. So this mold base creation or mold wizard will also be included in the whole syllabus. And in validation you can also check it for molding, means if material will fill the complete punch and cavity, that part is also there. Doing the complete this simulation, whatever mold that you make, it will simulate on the screen that if it is moldable or not, or how the mold will work complete. That will also be covered in the syllabus. Then you can check for the mold quality and easy fill analysis. That means if the complete molding will create any kind of warpage, or some shrink mark will come, or there will be some breaking, or it will fill or not, that also can find it out. So all those options will be taught in your syllabus. So just in single system you are able to create component. Okay, you can create your component, you can create the mold, you can put it for manufacturing, or you can send it for 3D printing also, and that will cover all your requirement of digitally manufacturing those components. Once it is done, then you can check it for the inspection also. Okay, that module is also there. And going ahead, I would like to just say thanks.